Okay, this is IM1 and we are doing lesson 5-5. So what we're looking is how to solve an exponential equation. We've learned what an exponential equation is, but we need to figure out how we could solve it. So the big concept to take away from this section is that if two numbers have the same base and they're equal, then the exponents also have to be equal, right? If we wanted to think of that another way, we could think of it as 4. I'm going to use the equation feature here so you can see it. So if we said 4 squared and we said that it was equal to 16, that makes sense, right? Because 4 times 4 equals 16. Or that is also 4 squared. So we can use that property and we can solve equations that have the exponent here. So here we have 3 raised to some power is equal to 81. And we don't know what that power is, right? That's what we have to solve. So we can use a calculator over here and we can look at it. So we're going to have 3 times 3, that's 3 squared. That's equal to, our answers over here is 9. Okay, so that doesn't equal 81. So let's do another 3. So that's 3 cubed, or 3 to the third. And so that's equal to 27. So that's not enough. So let's do another 3. So we have 81. So it was 3 times 3 times 3 times 3 equals 81. So what I can say is that 3 times 3 times 3 times 3 equals 3 to the fourth, and that's equal to 81. So that means that in this case, our value of x is equal to 4, right? Because the value, the variable, the thing we didn't know that we needed to multiply 3 by to get it to 81 is equal to 4. So our answer is x equals 4. All right, let's try another one. So what is the solution? I'm going to clear this over here. What is the solution of 4 raised to some power equals 16? Well, we know that since we switched it to the other side of the fraction line, we know that the exponent is definitely going to be negative. So in this case, the exponent is going to be negative because we put the number in from the numerator to the denominator. So one equation, 4 raised to something, we don't know what, but we do know that it's going to be a negative something, is equal to 16, or 1 over 4 raised to some power. I'm going to put a question mark again, right? So how do we get to 16? Well, let's see. 4 times 4. Oh, 4 times 4 is 16. So 4 squared. So in this case, we know that 4 squared equals 16. So that means that 4 raised to the negative 2 is going to be equal to 1 over 16, right? So our final answer is x equals negative 2, right? Because if we replace negative 2 here, we get 1 over 16. All right, let's do another one. So let's do this one on got it. So we have 7 raised to some power is equal to 343. All right, let's try that. So we just need to take, and we can take 7 and we're going to raise it to some power. So 7 times 7, 49, so not enough. Let's do another one, times 7, 343. So that's our answer. So we had 3 sevens. So I can't put in anything because this is one picture, but we can say that x is equal to, I'll put it right above. I think I can do that. Nope. All right. Okay, so I cropped these pictures really fast, and what I can say is that 7 raised to the third power is equal to 343. So that means that x equals 3, right? All right, let's try this one. So we have 6. We recognize in this case, again, we're going to have a negative exponent because we have a fraction. And let's figure out how many 6's does it take to get to 216. How many repetitions of 6 does it take to get to 216? That's what we're asking ourselves. That's what x is going to be equal to. So let's find out. So we have 6 times 6, not quite, times 6. So 3 repetitions. So it took 6 times 6 times 6, or 6 to the power of 3, then x equals 3 again, right? And it doesn't always equal 3, obviously, but it took 3 to get to there. And since this is in the denominator, I don't know how to spell denominator. It'll spell it for me. Isn't that the great part about spell check? We know that x actually equals -3, right? So in this case, x equals -3. What if we given an actual problem, right? Wow, this is an algebra problem here. So how are we going to do that? Well, we're going to break it down again. We're going to go ahead and we're going to figure out how many repetitions does it take to get 2 to 1024, right? Let's find out. So we have 2 times 2 times 2. We know it's probably going to be a lot. Times 2 times 2. Oh, times 2. Oh, not quite. Nope. We're getting there. All right, there we go. So how many times did that take? That didn't work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 2 raised to the power of 10. I can write that in the 2 raised to the power of 10 is equal to 1024. We know that this time, again, it's a negative, right? So what we can do is we can actually set them equal to each other. So we can say x plus 4 equals -10, right? We know that this has to be a -10 to make it a decimal. All right, and then it's a super easy math problem, right? It's a super easy problem to solve. We're just going to subtract 4 because it's plus. We're going to subtract 4 from both sides. So that means that x equals -14. And that's our answer, right? That's where we can stop.